finding a tangent to the graph of a function, say y is equal to f of x, right? By definition, the slope of the curve at a point, this is the curve, at the point when you've got x equal to 0, that's kind of like y sub 0, which is f of x sub 0, is a number m, which is what? It's the limit of the secant line, okay, becoming, I guess you can say, transforming into a tangent line because your h will go to 0. See, this x sub 0 plus h and x sub 0 is the gap between x sub 0 and add another distance of h. So when that h becomes smaller and smaller until it reaches 0, then you've got the slope of the line tangent to the curve at the point P. So example 1, find the slope of the curve y equal to 1 over x. Okay, what does that look like? You've got the curve 1 over x, and it's at the point x equal to a. So x equal to a is just any number. Let's say that's a. That's the slope of the line. Okay, tangent. Let's say that's the line tangent to the curve. What's that slope? That slope is this number m. Okay, next, where does the slope equal to negative 1 over 4? And what happens to the tangent to the curve at the point, any point, okay, as your a changes? Well, let's go to the next slide and work on the first part, letter A. Okay, so find the slope. Based on the slope, it's equal to f of x plus h minus f of x over h. Take the limit as h approaches 0. Okay, so let's, since x is a, so we put that there instead of x, we replace it by a. And then we go ahead and continue by using the function itself. So it's the limit of 1 over a plus h. Remember, you replace the x by a plus h minus f of a, which is 1 over a. So 1 over a over h as h approaches 0. Okay, when we do a fraction over a fraction, that's kind of like over 1. So this is the same as the limit of when you have a fraction. So it's 1 over a plus h minus 1 over a. It's the same as what? It's the same as multiplying by the reciprocal, 1 over h, as h approaches 0. Okay, let's keep going. So that's going to be the limit. Get the common denominator here, which is a plus h times a. So you got to multiply the first 1 here by a minus a plus h times 1 over h. Okay, and then as you notice that a cancels, so far what we have is the limit of minus h over a plus h times a times h. And since h is not really going to 0, equal to 0, it's just approaching, we can cancel that. So now what's left is the limit of negative 1 over a plus h times a as h approaches 0. So if this goes to 0, the whole thing will now be equal to negative 1 over a squared. Okay, so that is the slope of the line tangent to the curve at any point where x is equal to a. Right, so there's the line tangent to the curve. Line tangent to the curve. What is its slope? The slope is 1 over negative 1 over a squared. And if you notice, those slopes of these lines tangent to the curve will all be negative because they're all sloping downward. All right, so what's the question for letter B? It says, where does the slope equal to negative 1/4? That means what we're going to do is to find a so that the slope is negative 1/4. So now you take negative 1 over a, equated to negative 1/4, and when you cross multiply this thing, what do you get? You're going to get 4 equal to a squared, which means a is equal to either plus or minus 2. Say this is 2, and that's negative 2. Okay, so that's the slope of the line tangent to the curve at x equal to 2, or a equal to 2, and then right here at a equal to negative 2. And notice that these two lines are parallel because they have the same slopes. All right? So, and then in letter B, remember, oh, we forgot to answer that question in letter A. Okay, it says what is the slope at the point x equal to negative 1? So going back to that number, so when m is always negative 1 over a squared, replace the a by negative 1, then m would be this one, because you go negative 1 over negative 1 squared, so it's negative 1 over 1, so that's going to be minus 1. So as you can see, if x is equal to negative 1, this is the slope. The slope of this line, this particular line, would be negative 1. All right? Okay, so what can we observe? So let's answer letter C. It says what happens to the tangent to the curve at a point a and 1 over a as a changes? Okay, well, if your a is close to 0, as you can see, the lines would be very steep, and it's going to be negatively steep. And then as you go further out to as your x gets large or your a gets large, the slopes are becoming more of a slow descent. So it's kind of gradual descent until it approaches a slope that's equal to 0. Same thing when you go from the left, when you come from the left. All those a that are getting close to 0 in a negative way, then they'll have these lines that are steep and sloping downwards. And then when you go out further to negative infinity, the slopes become more and more close to 0. Right? So rate of change at a point. So when you say rate of change on an interval, okay, so if it's a rate of change on an interval, that's your delta y over delta x, which is your average rate of change from the interval, from x1 or a to b, x1 to x sub 2. Now, if you have a rate of change at a point, then it's going to be, you take this expression, all right, and then you take the limit as h approaches 0, so it's going to be the slope of the line tangent to the curve at x sub 0, all right? So by definition, when you have the derivative of a function at a point x sub 0, it's denoted by f prime of x sub 0. It's really just the slope of the line tangent, where at a particular point when x is equal to x sub 0. All right, so the following are all interpretations of for the limit of the difference quotient when you let h approaches 0. So all of these mean this thing. Okay, so it's the slope of the graph of y equal to f of x at that particular point x sub 0. It's the slope of the tangent, so they both mean the same thing, to the curve. And it's the rate of change at, it's not through an interval, but at x equal to x sub 0. And lastly, it's the derivative at a point, okay? At a point, so that's the difference. This is what we call the instantaneous rate of change. And the other one is, when it's over an interval, it's what you call the average rate of change. So that's what the next slide is going to be about.